All right, good evening, everyone, and thank you for joining us for this presentation. My name is Mark Tomzak. I am a mentor for programming with Beatty Bulldogs, that is Team 2051 out of AW Beatty Career Center. And what I'm talking about tonight is using Git and GitHub for FIRST Robotics. Git and version control in general have been a game changer for how software is written in the modern era. And I'm hoping to give everyone enough information to take advantage of it if you have not used it in your team yet. And if you are already using it, hopefully I'll be able to provide some suggestions for how to improve your flow. Just a quick overview of what we'll be covering. We'll start with a top level what and why of version control, drill down into Git specifically and the online service GitHub. We'll do a couple of demonstrations of how to synchronize code back and forth into and out of GitHub, and talk a little bit about sort of etiquette for presenting a repository online for public consumption. So before we dive all the way in, I'm going to start with the Socratic question: what is version control? If anyone is familiar with version control in general, feel free to chime in and let us know what your thoughts are. Cool, that was my not so subtle way of gauging how much experience everyone has with the topic, so we will dive in. So consider editing a file. You make a few edits to it. And then later on, you come back and you make some changes. And later on, perhaps other people come in and make changes to the same file, especially if it is robot control source code. This is likely. Later on, you decide that some of those changes were maybe not so great. Maybe you've made changes to your code and broke the robot. You want to go ahead and roll back. If you are using a basic code editor and your file system, this can be a challenge. You'll probably have to do this by hand. And what I have observed teams will often do in practice is backstop this problem by saving multiple copies of their code into different directories. The downside of that approach is that now you have a collection of unrelated directories, and the question of what code you should be running on the robot can become complicated. So version control is a system to sort of automate management of those kinds of questions. You can keep track of changes made to a file over time. And as your file grows changes, if you find you want to reverse to an older version of the file, it's easy to roll back. And this model is not limited to one file. Version control tends to work on an entire directory tree underneath your file system. You can think of individual versions as sort of checkpoints or snapshots in time of what your entire project looked like. In Git, these are called commits. And the version history does not need to be simply or strictly linear also. There are ways that you can branch off into sort of parallel models of the history of your file. For example, a lot of teams like to keep a branch of their history around for specific versions of their code that they used at specific times. It can also be useful if you want to make some experimental changes to branch your main repository and make your changes in sort of a parallel universe, while the main repository can be used as code that is always ready to be landed on the robot and used. The overarching theme here is that version control allows you to make changes without fear. And that pretty much completely alters the way that you write code for the robot. This clip art is the thing that you get near the top of the search results when you Google no fear these days. I could not tell you what that is the logo for. So there are a couple different version control systems in the world. Git is one of the more recent ones. It's a version control system developed by Linus Torvalds, who's the same author as the Linux operating system. It's a distributed version control system, which means that every user of a given repository has a full copy of the repository. So once you've copied the repository to your own local machine, any changes you make to it, they have no bearing on the rest of the world. Bob can have a copy, Alice can have a copy. We'll have a copy running on the driver station for the robot. And then we have a central copy up in GitHub, and all of these are their own copy. When you use a system like GitHub, in practice, it tends to centralize your information, but be aware that the fact that it's distributed is key to the way GitHub operates. Key to the way that Git operates. So Git is a graph-based version control system. Every commit is a node in a forward-pointing graph. You share history between machines by synchronizing your copy of the graph to somebody else's copy of the graph using push and pull commands. So that's Git, the tool. GitHub, the service, is an online service that hosts people's repositories. You set up an account, you can create one or more repositories, and the contents of those repositories can be synchronized to whatever machines you control. It also provides online services for synchronizing data between repositories, and we'll get into that a little bit later. You can use GitHub for free. They also support paid accounts, which have some additional features. It has a very convenient browser interface for managing and controlling your repositories. So we're going to go ahead and dive in on using GitHub. I'm going to go ahead and link to a remote repository and pull from it. Just a quick overview of the steps that we're going to do here. Minor modification of these steps. I actually cloned this repository and will be using a copy of this that I control. If you'd like to follow along at home, if you have Git VS Code and the VS Code Git plugin set up on your machine, you should be able to follow this process. So we're going to go ahead and get started. Switching over to Git. There we go. So if I come over to GitHub, I have several repositories that I created. One of them is my copy of the Git Flow Code Lab. This is not a repo that I created, but what I did was I forked another user's repo. Forking creates a clone of the repo that you control, and you can do whatever you want to in this repo without having any bearing on the one that you originated it from. So having come over to this repo, if I want a copy of this on my local machine, I go ahead and click this code green button here. This is the URL of the repository. Since I have already installed Git for Windows on my machine, I have a Git bash here option in my right-click directory. There are several shells to controlling the Git tool. My suggestion is it is going to be useful in the long run to learn the command line shell because it's the most common one and it maps most directly to all the capabilities that Git has. There are some other shells that are quite good. I'm very fond on Windows of Tortoise Git, which kind of integrates into the file system to make it easier to manipulate Git from the right-click menu. You can see my Tortoise Git drop down here. But today we'll go ahead and use the command line shell. So the command to get a copy of a Git repository is git clone. And then I need to tell Git what the source of this repository is. In this case, I'm going to paste in the link that we copied from the website. Boom. I now have a Git Flow Code Lab directory. The most interesting thing right off the bat, and on Windows, you only see this if you have show hidden files turned on, there is a .git folder inside of this repository. The presence of the .git folder is what makes this a Git repository. All of the Git tooling revolves around, is there a .git folder somewhere up the directory tree from where I am right now? You basically never need to open that folder, but just be aware that its presence or absence decides whether or not you're operating inside of a Git repository. Now that I have a copy of the Git repository, I can go ahead and open it in VS Code. That was the wrong VS Code link, so I'm going to close that one right back out. I want the VS Code that is integrated with the FRC libraries. And in VS Code, I just hit Control-K, Control-O to pull up my file browser so I can get to that project. Select folder. And this is a very useful feature VS Code added because we just pulled in our content from the web. It wants to confirm that we trust this content. Since it's coming from my repository, I trust it. All right, I should have a working copy of a little bit of robot code here. We have our robot container. We have our robot.java. If I control F5 this, I should be able to go ahead and just run it. And I believe that is running. Give that one more try. Ah, there we go. Yeah. So we have some running robot code, and we can see in the in our console here, there's a PJ has made an example. All right, so let's go ahead and make some changes to this. I want to go ahead and add a new subsystem. And to do that, we're going to go ahead and pop over into our subsystems. And I'm going to create as a peer to the chassis subsystem here. And we'll go ahead and just call this Marquee Code Lab. Part 1. It's an unusual name for a subsystem, but there you go. Going to want to go ahead and add a constructor here. And in the constructor, we're just going to confirm that this was created. And since we created a new subsystem, we're going to have to go ahead and add it. Okay. As always, give that a quick test, make sure it did what we wanted it to. Aha. Oh, I forgot to include subsystem base. Here we go. Okay, and my new subsystem is indeed in there. All right. So what we have right now is we've made some local changes to our repository. None of those changes are yet in version control. If we go back to our command line and hit git status, quick interrupt, by the way, it is hard for me to see my screen shared from this point of view. Is this text big enough for everybody to see? Let me know if not, and I'll see if I can zoom it in.
On my screen, it seems to be fine. It might be a bit harder to see in the recording, though.
Okay, yeah, I forgot about the recording. Great point. There we go. So the command git status shows me, oh, excuse me, we are one too high. I just changed directory down into our git flow code lab. Incidentally, this command line now shows me what branch I'm on. We'll talk about that more in a bit. So the status command tells me what is currently modified and untracked. Modified files are files that the repository knows about and knows that I've made a change to. And untracked files are files that the repository doesn't know about. My new class is untracked. So to add the new file, I'm just going to go ahead and say git add source main java com SCRA code labs, and I can start using tab. For the rest of the modified files that it already knows about, I can say git add update and git status again. All right, what we're now looking at is we've got one file that's changed. We have one new file, and these changes are staged for commit. Now, to go ahead and actually commit them, I'm going to say git commit -m. -m is the commit message, which we'll get to in a bit. Run that. And we've got, it reports that it succeeded because it made 2 changes to files with 13 lines of code change. Our status now shows there's nothing to commit because we made the update. If I want to see the history of changes, git log shows me here's the initial commit from when I cloned the repository. And if there had been other changes before that, the clone would have taken those changes in, and we would see those too. And here is the new commit. So we now have a 2-node graph of the initial commit and some changes that represent the new commit. And the new commit is where we are right now. Having done all that, we're going to go ahead and go back to our GitHub repository. Let's refresh the page. And I'm going to go down into subsystems. Notice that my new subsystem isn't here. The reason is all the changes we've made so far are just on my local computer. We have not pushed any of those changes back up the chain to be reflected in GitHub's copy of this repository. So if we want to go ahead and do that, we're going to use the push command. And it will probably take me a couple of tries to get this right on the first go. Let's find out. Ah, lucky me. So this is kind of dense information, but the key point is resolving deltas means it figured out what the difference was between the remote copy and our local copy. It sent them to the right location. And this is just showing how this is showing the relationship between the old, or our local copy and the new remote copy. If you try this at home, you might find that it instead kicks out a URL you need to go to. GitHub has an authentication mechanism to confirm that you have rights to push to a repository. But since my push succeeded, I refresh the page, And there is the subsystem that I just wrote. All right. So that's how you make changes to a repository that you own. If you want to make changes to a repository that somebody else owns, there are a couple of ways to go about doing that. Pull requests are a feature on GitHub that allow you to request that somebody else pull in changes that you've made to your repository. Oops, sorry about that. These work both between repositories owned by different people and between branches in the same repository. Once a pull request is accepted, your changes become merged into the target branch of the destination repository. So if anybody wants to try this feature, what I recommend is if you have a GitHub account set up, go to the GitHub user interface, go to github.com/fixermark/gitflow and up in this area of the user interface where I have the go to file, the add line, code. No, excuse me, I'm sorry. So it was under my menu of pictures of people logged in. I couldn't see it. Up in the top right of the user interface, there is a fork button. If you log into GitHub, you go to my repository and you hit fork, you will receive a copy of my repository that you can make changes to. Clone your copy and go ahead and feel free to make changes as we move forward here. And if you want to try pushing your changes back to me, you'll be able to create a pull request, which I'll show you how to do in a little bit. So we will go ahead and follow through on that. We'll do another dive in. This time around, we'll create a pull request and try and get that request added to the main repository. Now, since I am using my copy of the repository with my main, I'm going to demonstrate this by using a separate branch. So let me show you how that works. A branch is like a branch in a tree. You have a shared history between two nodes. And then there's one commit that has some changes, another commit that has different changes, but they have the same ancestor history going back in time. There are a couple ways to create branches. There is a git branch command, a git checkout command that you can use in the shell. I'm actually going to go ahead and use the Visual Studio user interface for this because there is a git create branch command. And I'll just name it subsystem 2. Right now, subsystem 2 and main are exactly the same. They both reference the same commit. If I go to the command line here, I can get all of the branches. And this asterisk means that subsystem 2 is my currently selected branch. So any changes I make are going to appear in subsystem 2. And I will go ahead and make some changes. Let's change the message that we generate here. Give that a quick test. I'm pedantic about running tests before I commit my changes, but that's because there are a few things more annoying when sharing a Git repository than somebody pushing you broken code. So down here we can see ArcT subsystem online. So that change worked. I'm going to go ahead and use the Visual Studio shell to commit my changes. This does the same thing as the command line. It just has a graphical user interface on it. So I stage my change by hitting the plus button. I type in a commit. And the check mark here We'll go ahead and commit my changes. Visual Studio calls it publishing the branch, but this is the same as git push essentially. And that appears to have succeeded. Let's make sure. Going back to my Git repository. Right at the top, it tells me subsystem 2 had recent pushes less than a minute ago. And it even recommends that I probably want to pull request this. So before I do that, I just want to make clear what our current situation is. If we go back to this slide, currently, I have a branch that has come off of the main trunk of the program. And what I want to do is remerge it to the trunk, creating a new commit that is now part of the trunk. So we will go ahead and give that a try. So if I go ahead and hit this compare and pull request button, down here, I can see the changes that were made. Up at the top, we can see that I'm going. So interestingly enough, because this repository is actually a fork of the Steel City Robotics Alliance repository, this has not defaulted to trying to merge this branch into my repository. This is defaulted to trying to merge it into Steel City Robotics Alliance. That might be what I want to do, but for the sake of tonight's demonstration, I'm just going to merge from a branch I control to a branch I control. And here's the change that we expected, which is very simple. What I will now do is create a pull request. All right. So the pull request bundles up the change that we want to make and then provides an opportunity for somebody else to decide that that change is okay. This is a tool you might use to make changes to somebody else's repository. It's also a tool you can use on your own team to keep changes to the code off your main branch and only add them to the main branch when you are satisfied that the changes are correct. Over here in Files Changed view, we can see the changes that were made. It's just the one change, so it's not too terribly exciting. We can actually, and there's a couple ways that you can look at this. I'm actually going to split it out, make it a little easier to see. So here you can see on the left what the file used to look like, and on the right what the file will look like if we accept this pull request. That looks good to me. Since I have all the rights I need to do so, I can just push the merge pull request button. And if we go back to our code, we can now look at the history. And the history has changed from that branching structure back into a straight line because we made a change and then we just pulled that change right in. While I was doing that, did anybody else fork the Fixermark Gitflow code lab and try to make a change? Sounds like no, and that is fine. I just was going to take advantage of it if you had. If not, we will go ahead and demonstrate the next step a different way. Before I move on, does anybody have any questions? All right, sounds good. So the next thing I want to talk about real quick is I want to demonstrate a conflict. So Git is extremely smart about taking content with overlapping history and merging that history into one coherent view of the world. But it isn't magic, and there are times where it will come into challenges with that. So let's go ahead and demonstrate what that looks like. I'm going to go back to the main branch, and I'm going to do a quick pull to make sure that I have all of the changes that we've made. So this says Mark II subsystem online. Now I'm going to make two branches. This, you can imagine this happening from two different programming subteams working on two different related pieces of the robot. So I'm going to create a new branch. We'll call it conflict 1. And in conflict 1, I'm going to say Mark II subsystem operational. And I'm going to create a second new branch. We'll call this one conflict 2. And the text will say Mark II subsystem ready. We're going to go ahead and publish both of those. There we go. And if we come back to GitHub, we should be able to see that we now have a conflict 1 branch and a conflict 2 branch. We actually should have. Yep. In this view, by the way, we can see our list of branches. Here's our main one. The subsystem 2 that we merged in earlier still exists. If we select it, we'll go back a little go back in time to when subsystem 2 was in existence and our two conflicts. So we'll go ahead and accept conflict 1 real quick, making sure that I go to fixer mark. And that one works fine. Here we have conflict 2. So I'm going to create a pull request on this one. This is actually mildly surprising me. Give me 1 second to figure out where I went wrong. So Git is actually outsmarting me here, which I am not displeased about. Git is not seeing that there's any particular problem with this history because it's a very clear change of text from one to the other. I'm going to try and force it to become convinced that I need a change here. So let's try synchronizing main, bring myself up to speed. I've actually surprised myself that I am not able to recreate the steps to create a conflict right now. That's okay. We'll talk through it. So in essence, a conflict is where Git cannot decide which of two histories of a file it should use when it decides to merge a file together. When that happens, it'll present a user interface that asks you to pick which of the lines of code from the past history should be the one that you use. And essentially, all you have to do is pick them and then add the files to the staging using git add and commit them. I'm happy to answer more questions about that later on, but let's go ahead and move through the rest of the presentation. And I should be able to back that up. Thank you, David. That's a much better idea. Let's do that. Hold that thought. I'm going to take David's suggestion, and we're going to actually change the history by deleting one of these files. So back to main. In main, we're going to go ahead and delete this entire subsystem. And in conflict 2, we're going to make a change to the text. All right, now, if I ask to merge the changes from main into conflict 2, so the merge did not succeed because we now have a conflict. And if we look at git status, our conflict is that the file was deleted by them, and them is always wherever you are pulling from. So that would be your remote repository, or in our case, the main branch, because we tried to merge into conflict 2. If I go back to Visual Studio, Visual Studio will provide me some information indicating that we have a conflict, and I can decide how to resolve it. We have a conflict here because the history looks like this. In one branch, this file was deleted. In the other branch, this file was changed. And Git has no way to resolve those two histories. What, do I want to change the file, or do I want to delete it? So it throws up its hands and asks for human intervention. And the way we intervene in this case is we can go ahead and either accept all current, which is what our file looks like, accept all incoming, which is what the file looks like from main, which is where it's deleted. Or we can just stage the file as is. In this case, staging it as is will do the job. And we can keep our version. And then I'm going to go ahead and add a commit, which merges that branch into conflict 2. There we go. If we look at the log, and we've got our head is now pointing to change from ready to prepared. And the file is not deleted, it is still here. All right. So let's talk through just a couple of recommendations for if you are posting a repository to Git. So in general, it is good etiquette for every repository on GitHub to have a README file and a license file. The README file is a novice user's introduction to what this repository is for. It's where you put explanation of why the repository exists, what it's supposed to do, how to make use of it, and how to change it if somebody wants to make changes. The .md suffix is for the markdown syntax. There are a couple of different accepted README syntaxes. Markdown is nice because it changes symbols like hashes or stars into headers or bulleted lists. So it makes for some very readable README documentation. It is also extremely recommended that you have a license. Without a license, technically speaking, nobody is allowed to legally use your code, which is probably not what you want if you have published the code and made it widely available for everyone to see. The license clarifies legally how people are allowed to use your code. I generally recommend teams use the MIT license because it's very straightforward. The legal coverage it basically provides is it declares that your code is used as is. So if somebody installs your code on their robot and the robot bursts into flames, it makes it extremely clear that that is not your team's fault. And the license also makes clear how teams are allowed to reuse your code, which in the MIT case, if I recall correctly, is with attribution. As long as they say that they got the original code from your team, they're allowed to make whatever changes they want to your code and use it on their robot or in whatever projects they choose to use it. In general, just a note about publication for GitHub. This rule was omitted from recent games, but it has shown up in past years. The rule for code reuse was traditionally that you may reuse any code that was written in the past as long as that code was published and made publicly available prior to the kickoff for this upcoming year. So first, significantly incentivizes, in general, reusing code. As we all know, rules change year to year. I can't guarantee that this rule will come back in any given year, but it has been there in the past, and my gut tells me it will show up in the future. I'm pretty sure that they removed it for a couple of years due to COVID creating complexity with the competition in general. So of value, when making changes to your code are two Git features called, or two Git features. One is tags and one is the comments. The comments are very important, especially if your team has more than one programmer, because they are the way that other users can tell what your intent was when you made changes. Without comments, the only way to know why you made the changes is to read every line of code that was changed and guess. That's no fun for anybody. So I highly recommend the more detailed you can be with your comments, the better. In general, when you're working in a commercial application, writing code for a company, writing code in the modern business world, when you commit your commit will be tagged with your username. This works very well in general. First Robotics tends to be an exception because so much coding is done on the driver station itself. And as a result, all of the commits that come off the driver station will almost always be committed as the user who was logged in at the driver station. And nobody remembers to change their login when they pick up the driver station. So I highly recommend, as a special variant for writing code in First, that you tag the code that you're committing with your name. The other reason that these tags are very useful is that there's a feature called git blame. And what git blame does is when you apply it to a given commit, I'll go ahead and pull up a specific file here to show off. Git blame will show you for each line of code the commit that caused that line of code to change. So if I run the blame on this file that we've been editing on, we can see that a couple of these lines of code came from the original edition of the subsystem. But over here, Mark Tomczak changed the message to operational in a separate commit. And now that I know that, I can look at the commit history to figure out why that might have happened, or I can go track down Mark Tomczak and say, hey, the text was fine as it was. I don't quite understand why we made this change. What's the plan here? Here's some examples of what I recommend for good commit messages. Always remember that when you're writing a commit message, you're writing it for other people who aren't you. You are also writing it for yourself 6 months down the road. And you would be surprised how little you'll remember about why you wrote this code in the not too distant future. So in general, be specific. And when you're writing code in First, get in the habit of adding your name as a little ellipsis tag, just so it's easier to tell when all of the commits in the project are from the driver station that this was actually added by individual team members. One additional feature which is nice to have is the git ignore file. So .git ignore can live in any directory, and it's a text file containing individual patterns that, as the name says, Git will ignore. As we noted, or as we saw earlier, when I add a new file to Git, Git starts with that file unstaged, but it lets me know the file is unstaged so that if I want to add it later, I can. Many kinds of files are files that you never want to stage. Things like build artifacts. I can probably show us an example of those right here. So everything in this build directory is created by Visual Studio, actually created by Gradle when the project is built. And I never want any of that to go into Git because I want to create it locally every time that I use it. So the git ignore file in this project is already populated with all kinds of patterns for files that we want to remove. In general, oh, I'm mistaken. Depending on the shell you're using, some shells will add the feature of right-clicking on a file in the Windows file system to add it to git ignore. Changing code as a group is a process that your team will decide on what they want to do. Every team is different. I've worked with teams that just make all the changes in main. I've worked with teams that are very disciplined about branching a change before remerging it into main. There are, in addition to merge, there's a command called rebase, which kind of changes the history of a branch to make the branch look like it came off of a point closer to the future. Some teams enjoy rebase instead of merge. There are many ways to do this. You can also have a single repository that everyone has the password to, or you can have a repository. You can have everyone on the team fork the repository on GitHub make changes to their forks, and then merge the forks into the team's central branch. GitHub also offers the ability to protect your main branch, which basically means that no one is allowed to push a change directly to main. The only way that you can change main is to go through the pull request process. All of these are features that your team could choose to use. The most important thing is that whatever your team decides to do, write it down and be consistent, which is pretty much an overarching rule for everything we do in FIRST Robotics. The most important thing with any large scale, complicated group project, write decisions down, be consistent about executing on them. And that is everything we have on this topic. Does anybody have any questions I can help answer? All right. Hearing none, I think I can go ahead and wrap us up. Everyone, thank you very much for coming out.
Question.
Go ahead.
So our team, we set up something with like GitHub Actions. Have you done stuff with that?
I have. I'm not sure I am savvy enough with it to demonstrate it right now, but I can very quickly explain it. So Git itself, and by extension GitHub, has a feature where when you, it has a feature of triggered actions. When you do some things to the repository, create a branch, commit a change, run the merge operation, you can basically tell your local copy of Git, oh, also every time you do this, run this script. And whatever the contents of that script is, Git will do that every time you run the script. I actually maintain a blog at personalblog.fixermark.com. I'm not sharing the link because I'm not proud enough of it to share the link. But the way that that blog works is that that blog is a Git repository on my local laptop. I am maintaining a Git repository on a server I own. And when I push to that server-side repository, an action runs that takes the changes to the blog, runs a program to turn the text files into HTML, and moves that HTML into a location on the server where it can be served. Those are the sort of things you can do with actions. GitHub provides, I think, several pre-populated actions, in addition to some limited customization. Sorry, one second. So there is documentation available online for how to set up actions, but actions allow you to do things like run a verification on the code before it is committed to make sure that it fits some requirements. There are tools like linters and formatters that make it easier to maintain a consistent look and feel to your code, and you can run those as an action before you commit the code, things like that.
Another really cool thing that you can do with actions is if you have like JavaDoc or Doxygen or something similar, you can actually set it up so that it will automatically run and then publish it to a GitHub Sites page every time you commit. So like for an example of that, in the Titans 2022 rewrite of our robot code, we set up something to do that.
Oh, that's really cool. I like that. Was that David?
Yeah.
David, do you have a link to the documentation that gets generated from that process?
Sure. Give me a second.
Drop it in the chat. I'm going to go ahead and pull it up on the main screen here. That's incidentally, that's a great use of actions. I can tell you in my day job, we use them for what's called continuous integration. So there's a program that runs, and every change that hits the main branch, this program automatically compiles it, runs a battery of tests, and then does a bunch of housekeeping, including tagging it for historical purposes and uploading a copy of all the compiled binary components to a source code or a program repository that we can pull down in various places in the company.
Yeah, I sent a link to the GitHub repo, which has like the actions config file in it, and then a link to the docs that get generated from that too.
Excellent. So here is our config file, or I'm sorry, here is our repository. And you can see in Titanium Titans, here's the actions they have configured. Let's see if I can, I don't know how far it's going to let me get on these given my permissions on your repository, but let me take a quick look at some of your actions here. Yes, this action triggers on deploy. And, oh, very nice. Yeah, it actually does let me see what the action does. That is cool.
Yeah, so you can actually use like community made like action scripts, and there's quite a lot you can do with it. Basically, just anything you can run as a command in like a Linux terminal or a Windows command prompt, you can put into an actions file and have it run on push.
Yeah. And on push is the command that, or that's the hook that triggers when you push code from a local machine into the GitHub repository.
Yeah.
Here's the deploy action. And if I understand correctly, when the deploy action runs, it updates this website here.
Yep.
By reading the source code and generating the documentation. That is a very clever solution. Does anyone have any other questions or comments or cool things that you've seen teams do with Git? There was one other thing that somebody brought up that I wanted to mention. Let me pull up the chat real quick to confirm. Thank you, David. This was also your story. So that was as an example of why these tools are useful. There was a team that competed this year. Day of competition, their driver station laptop died.
All of the USB ports on it just spontaneously got fried.
Yeah, which is something you never think of happening. And with the number of teams that compete, times the number of years the competition has gone on, it is guaranteed to happen to somebody. So that would have been incredibly disruptive, but fortunately they had their code committed to Git and uploaded to GitHub. So they were able to relatively quickly source a laptop from another team and just pull their code down to that laptop and compete using that laptop.
Yeah, and they needed to make a change to their code because the robot wasn't driving, which is why they couldn't just use driver station.
That makes sense.
But this is also why I'd recommend everyone to like have LabVIEW and you know, like the Java/C++ tools installed on your laptop, regardless of what language you use. Is it just like if you ever get into a situation like that, it's really good to be able to have a backup.
That makes a lot of sense. All right. I think we can go ahead and just about wrap up there. Thank you again, everybody.
Thanks so much, Mark. Have a great night.
Thank you too.